In this video, we will describe the geometric distribution that has one parameter p. Consider independent trials, and each trial results in one of two possible outcomes. One of the outcomes is labeled as success S. The other one is labeled as failure F. P is the probability of success, and then 1 minus P is the probability of failure. Define the variable X as the number of trials until the first success appears. That is, X is the number of trials required to obtain the first success. So what are the possible values of X? Well, X couldn't be 0 or negative. X could be 1, X could be 2, X could be 3, and in fact X could be any positive integer. Now let's let n be a positive integer. So let's look at the event that X is n. Well, if X is n, it means that n trials are required to obtain the first success. Well, then the nth trial must result in success, and the first n minus 1 trials must result in failures. So the probability of the event that X is n is the same as the probability of the sequence of outcomes of the n trials, where the first n minus 1 trials are failures and the nth trial is a success. So what is P of f(f)(f)(s), where we have n minus 1 trials resulting in f here? So then that probability, because we are assuming that the trials are independent, this probability is the same as the probability of f multiplied by the probability of f probability of f probability of s. Now each we know that the probability of f is 1 minus p, so we get 1 minus p, and then the probability of s is p. There are n minus 1 factors. Each of the first n minus 1 factors here is 1 minus p, so this is equal to 1 minus p to the n minus 1 times p. Hence the probability that X is n is 1 minus p to the exponent n minus 1 times p, and here n could be any positive integer. Now here's so this is the PMF of the geometric. So X here is set to have a geometric distribution with parameter p, and this is the PMF. This is the PMF of X. The PMF, the probability mass function of X, is given by P of n, which is 1 minus p to the n minus 1 times p, and n could be any positive integer. Now what's the expectation and variance of this distribution? Well, the expectation of x is 1 over p, and the variance of x is 1 minus p divided by p squared. Now let's see how we can find I'm going to derive the expectation in this video, but I'm not going to derive the formula for variance. So let's try to derive the formula for the expectation. So the expectation of x, by definition, is the sum over all values of x, x times p of x. Now we know that the values of x in this for a geometric distribution, that the values are all positive integers, so n going from 1 up to infinity, n times p of n, which then is equal to the summation n going from 1 up to infinity, n times, now we obtained a formula for p of n. P of n is 1 minus p to the exponent n minus 1 times p. Okay, so we need to evaluate this sum, and to do that, the first thing I'm going to do is factor out p, and then I have n going from 1 to infinity, n times 1 minus p to the power n minus 1. Now at this point, let's recall the geometric series from calculus. So the geometric series, let's take the function f of x to be summation n going from 0 to infinity of 1 minus let's do the following, x to the n. So this is a geometric series, and we know that this is the same as 1 over 1 minus x. So if I take the derivative of f, what we are going to get is the summation n times x to the n minus 1, n going from 1 to infinity, and that would be the same as the derivative of 1 over 1 minus x. We can find the derivative of 1 over 1 minus x by using the quotient rule, or we can just use the power rule. So the derivative would be 1 over 1 minus x squared. Okay, so notice that in this formula that I have, so look at this formula here. In this formula, let's replace x by 1 minus p. So if we do that, what we get is, so here if I replace x by 1 minus p, I get exactly the sum that I need to evaluate. And here, if I replace x by 1 minus p, I basically get 1 over p squared. So we know that this sum is the same as 1 over p squared, which then is equal to 1 over p, and hence the expectation of x is 1 over p indeed. one can derive the formula for the variance in a similar way. Okay, so in the next video we will go over the negative binomial distribution.